Today, part one in a three-part series. We've got Electrical Diag 101 via Rust Belt. All right, first off, to basically understand how 12-volt electrical systems work, we're going to have to understand the very basic properties of the 12-volt system. Now, I can go in through and start giving you guys battery readings and everything like that, but I'm talking basic here. So we've got a whiteboard up behind me, and we're going to go through exactly how to visualize this part of the process. And what better way to be able to show this than with an imaginary garden hose. So we've got our spigot coming out of the wall here. This is our garden hose. And we've got it connected to our nice long hose right here. That is our garden hose. Now, when you turn the spigot on here, we're going to have flow of water. Now we've got to think of electricity in terms of water flow here as well. We've got first our voltage. The V here is our voltage. Now we have to think about that one as pressure. When you happen to put something here on the end of it, we've got a certain pressure that you're able to adjust with the little sprinkler head to it. So the voltage is how forceful the water is coming out of the garden hose. Now we're going to talk about amps. Amps is the second leg in our terminology for the DC voltage circuits that we have. Amps is going to be related to the flow of water. That means how much water is actually going to be flowing through this garden hose. For instance, if I have this one garden hose, we've got a larger diameter one, rather than if I use a smaller garden hose, if I want to push the same amount through, it's going to be a little bit harder and we may not be able to push as much through, so the amperage may not be as high, the flow may not be as big and as great. So that's how you think of amperage, is how much water is going through the hose. Then we've got over here resistance. That's going to be your third main leg of the direct current equation here. Resistance, that's going to be how much resistance to the flow that there's going to be. So for instance, like we take this garden hose and we put a big kink right here in the middle of it. We just put a big old bend and a kink to that one. All of a sudden, you're going to have very little water coming out here, but we're going to have a high pressure buildup here just before that kink. So that is going to be your resistance to the allowance of flow of the water in the system. Now, all of these three things, they have to happen in congruency of each other, which is why we've got the big old bad Ohm's Law sitting right on over here. Now, all three legs of the Ohm's Law, voltage, amps, and resistance, they have to act and mesh exactly together. It's kind of like the laws of gravity. It doesn't matter how much you're going to be changing it, it's always going to be the same no matter what. So if you change one thing in this equation, it's going to transversely affect how things happen elsewhere in that equation as well. We want to be able to find our voltage, and how we find that is we multiply our amperage times resistance. That is the basic Ohm's Law. Now if we go over here and relate that to our garden hose, we've got our voltage, which would be, say the pressure of water coming out of here would be, well, say we're trying to figure that one out. We know how much water is flowing through that. We'll say that one is 10 gallons per minute. 10 gallons per minute flowing through this hose. Now resistance, say we've got water flowing through our hose just fine here, flows just fine, but we do have a little handle and a trigger and a sprinkler end here, causing a little bit of a backup and a buildup of pressure in the system. This is going to be causing resistance value, and we'll say of, in electrical terms, we've got say a 2 ohms resistance. So as you guys can see with the equation that we have right here, to be able to find our voltage, we're going to multiply our amps times our resistance. In this one, easy enough, 10 times 2, that would give us a multiplication factor and make it 20 parts. So for this one, we would see a PSI of roughly 20 PSI coming out at this hose end. Now, like I said, everything has to work with each other. So if for some reason I raise my pressure, my resistance right here, so if I raise my resistance. That means I squeeze that hose a little bit tighter at the end to not allow as much flow to come out at the very end. Well, if I'm still going to push out 10 gallons per minute outside of the end of this hose, that means this end product, the pressure, is going to change. We're now going to be putting out 30 psi of water right here. So everything, like I said, has to happen congruently within that equation. And that helps us find out certain, I guess, factors in diagnosing electrical issues as well. If we're trying to figure out something in a circuit and trying to figure out where a resistance point is, we want to find out how much resistance there might be. And that's why we have the other two equations over here. If for some reason there's one leg of the electricity that you don't know or you're trying to figure out. So if we're trying to figure out how much amperage is flowing here, but we know our voltage, so in this circumstance, our pressure is 30, and we know our resistance value, that one's going to be even a factor of 10 in this equation. We're going to be dividing this here. 30 divided by 10 is going to be 3 gallons per minute in the flow of water if we're putting it into DC electrical terminology. All right, guys, now that we've got the entire theory out of the way, if you guys have any questions at any point about what I'm talking about with voltage, amperage, or resistance, you guys can go back to that point in the video. But now we need to understand the tools that we're going to be using to be able to diagnose our electrical issues, and that is our digital multimeter. This one from SP Tools, part number SP62011, is going to be the digital multimeter that we're going to be using today. Pretty easy, self-ranging. It's going to be automatically functioning in that version, and digital multimeters can come in all different shapes and sizes, cost amounts and values. I would recommend at least getting an auto ranging multimeter for the guys that are just starting out in things. Yes, they might not be the cheapest things to be able to kind of get a hold of, but they're going to be giving you the easiest factor of learning when we're going into DC voltage. So in today's video, the only function that we're going to be really focusing on is going to be our voltage functions here on the meter. We've got the meter turned on, we've got our leads here put into our positive terminal and our COM or negative terminal here on the meter. So what we're going to be doing is showing you how this functions in relatable terms to DC voltage. You've got to think of your multimeter as just a fancy automotive calculator. All it's going to do is it's going to take your voltage reading from your positive post and the voltage reading from your negative post and subtract the negative from the positive. That's all it's going to do. It's going to take both readings of voltage from those points and subtract out what would be your voltage drop in that system. So we're going to go over here to our fancy dancy little test platform from eTrainer Junior. This is going to be the platform that we generally set up. If you guys want any more information on these test kits, you can go to www.ceasusa.com or contact us through the phone lines there. These are kits that we are able to get and supply for you guys. And now later on in the series, we're going to be going through and showing you the different components that this test board does allow you to see. But in this version, we're just going to be using a very basic pad portion of the test platform. Basic setup, like I showed you guys, we've got it set on our voltage right here on the meter, and then we've got it turned on and we've got everything kind of zeroed out. So as you guys can see on our little test platform, we have our battery here in the lower right hand corner. And what we're going to be doing for nominal testing is we're going to have our negative lead on the negative post of the battery, because that is the overall end flow of the current in the circuit. After the electricity flows through whatever items or whatever modules or lights or whatever, it's going to go to a chassis ground, which will eventually go back up to the negative post of the battery for the negative return. So for our voltage sector, we're going to leave that one there on the negative post. Now we want to be able to find out what our voltages are at certain points in the system. We know, testing a good battery right here, we're going to be at just over 12 volts. So that is taking our positive reading which it is reading 12 volts. And after it goes through the system, pretty much reads 0 at ground. So that is why our meter reading is right at the 12 volt function. So we're going to go up into the system a little bit further, and we're going to turn on a light bulb. So but just before this light bulb, we're going to take a voltage reading right there. And what do we have? 12 volts. Now, when you were thinking back to this little flow of water right here in the hose, you've got your resistance value right there at the little sprinkler head. That is going to be like your light bulb in the circuit right there. So we're testing the voltage or the pressure in the system just before that. If we have 12 psi or 12 volts of pressure coming through the system, we know that it is going to be pretty much the same between the battery or the wall and right before the resistance value that we have going right there. So we know that we have 12 volts right up to the light source or our resistance point. Now, light, obviously, we have to use energy to create light. That is going to be resistance. Light bulbs are warm, they're hot when they're turned on. They have resistance of electricity to cause heat and light. So, how much of that voltage is the system going to be using? We are going to then just test right after our little light bulb right here, and we can see that we have right at about 10 volts. Now, when you're testing electrical circuits inside of a vehicle, you're wanting to test for voltage at certain points. Say for some reason this light bulb was not working, you can test at the battery. Yes, we have good active voltage right there. And then you can test just before your switch, which you can tell we have full 12 volts right there. After the switch, you can see we have nothing. It's because the switch is not on. Now, if for some reason that switch was on, but not showing any voltage, that's how we would then know that your switch is the bad part in the circuit. But now that we know it's on, we know that we have 12 volts after the switch. And if we were to test right before the light bulb, we still have 12 volts. After the light bulb, for some reason, if it was not lit and we still had 12 volts, then we would know that either the socket or that bulb would be bad as well. So things that are bad, they're usually going to be an open in the circuit, which is a massive amount of resistance, or a non-congruent bridge of electricity to the rest of the ground in the circuit. Now that we know more about the voltage in the circuit, let's talk more about the resistance values and amperage flow. And how we're going to be doing that one is we are going to be putting in some resistors. Here we're going to go over to our E-Trainer Junior fault blocks, and we're going to pull us out a 40 ohm resistor switch. Move this off. We'll set this one into place. Okay. So now we have this resistor switch, which is a 40 ohm resistor, into our circuit. Now it is turned off at this point, so the switch and the circuit are functioning exactly as normal. You guys can see here with our voltage reading that we have right at 12 volts just before the light bulb source in the circuit. So now that we switch our resistor on, we can see our light bulb dim greatly right there. Now just before the resistor, we can see our voltage value is still at 12 volts. Now after the resistor, now we can see that we've dropped all the way down to 7 volts, and that's because we added that extra 40 ohms of resistance. Let's go back over to the board to show that math-wise. So we're wanting to figure out how much amperage that we have coming through this circuit. We know our voltage value, so here V is 12 volts, over our resistance value, which we know we have at that point a 40 ohm circuit. 12 over 40 is what our amperage is equal to. Now see, I'm not good enough at math right there. So now after we do that calculation, we know that this comes out to 0.3 amps. So the less amperage that you have going through your system, that is how you can tell that that light bulb has dimmed quite a bunch, because we have less flow of electricity going through the system after that 40 ohm resistor. Now that's how you're going to use the actual math and equation to be able to figure out what is the missing leg within this system. So now if for some reason we don't know how much resistance is right there, then we need to use our meter in a different fashion. Now for a quick show on amperage, what we're going to be able to do is we're going to set our meter to our amperage spot, and now you also have to move your meter lead over here to the 20 amp spot. That is a different portion within the meter. It is also fused here within the meter. We're going to run a fuse in line, so we're not going to be damaging any of the internal components within the SP Tools meter. Really cool function that that one has, because most other meters aside from the SP one only usually run a 10 amp version spot within their meter. So something cool to check into for the SP meter. Now amperage is going to be tested just a little bit different. We can't just put this one on the negative and check between whatever spots would be there. We actually have to put the meter in series. That means we have to use the meter as part of the wiring in the diagram. So we have our amperage set right here. Now we're going to go ahead and pull out this little section of the circuit, and we're going to put our meter in place of that part of the circuit right there. And what reading are we getting? 0.13 ohms. So we know we have 0.13 ohms right there. So we're going to take our reading, and we know our amperage value. So we're going to put it into this area right here. That is 0.13. And we know our voltage value as well. Our voltage value is going to be 12 volts. Now we need to find what our resistance is going to be, and we'll go over to our handy dandy little calculator. Again, because I am not the human calculator, 12 divided by 0.13, guess what that one comes exactly out to? 40 ohms. The math does not lie. We know for a fact that that's what we grabbed out of our kit, because that is what's missing. You guys can see right here the 40 ohm resistor. So the math goes to show that is exactly how much resistance value is right there within that resistor. Don't take my word for it though. Now for the last portion of today's video, I want to be able to show you resistance values with the meter here as well. Now we're going to be putting our meter back into the standard function in the positive port, and then we're going to change our meter over to the ohms or resistance spot. And if you guys don't know what ohms looks like, this little symbol right there, that is ohms or resistance within your meter. In our meter right now, we are showing OL, and that stands for out of limits. That means there is no connection and there is nothing flowing through the meter whatsoever. If we touch our two lead ends together, we can see that we go down to a value of 0. That means there is 0 resistance whatsoever going between these two meter end leads. Now, what we're going to do is we're going to take our fancy 40 ohm resistor, because we know the resistance value of this one. We're going to touch the two ends to our meter, and we can see our reading 38.7, which is really close to 40 ohms of resistance. So if for some reason you're trying to find the resistance value of a certain point in a circuit, then that's how you can use your meter to find out the resistance value within this circuit. So for right here, if we want to figure out like what our voltage was, we knew that we had 0.13 amps. That's what the meter said. And then we know our resistance value. Right there, we just tested that resistance point, and that would go the same for if you guys were testing the resistance across, say, a light bulb or pretty much any kind of other usable switch or item. Anything that uses electricity is a resistance point in the circuit. So we know our resistance value was 40. So that 13 times 40, we know, we did the math and calculations up, that's going to equal 12 volts. So for knowing the 3 different legs of direct current electricity and knowing your 3 different variations of Ohm's law, that's going to show you pretty much any easy way to diagnose a vehicle's electrical system. Hopefully this was enough information for you guys to get started in on your electrical diagnostics career. Now I know starting off as an automotive technician is very hard, and pretty much getting into anything in the automotive world pretty much means that you need an electrician's background, because anymore there's up to 32 modules within these vehicles, so many electrical systems, you've got hundreds of miles of wiring within each vehicle, and you have to be very proficient within your electrical diagnostics to be able to diagnose pretty much anything from transmissions to air conditioning systems. This is the basis of which the modern technician in the automotive field has to be able to build your basics in the career. So hopefully this gave you guys a little bit of information leading into what you really need to know here within your career. Now, if you guys have any questions or anything about the meter that I used or any of the other systems, feel free to contact me at therustbeltmechanic@gmail.com or go over to www.ceasusa.com. You guys can email the tech line over there for information or questions about this or the SP tools. Thanks for tuning in today, guys. I appreciate it. You guys stay awesome.